Okay, next Math C video. Applications of vector product, the equation of a plane. Okay, so this is in 3 dimensions, and let me just explain this picture a little bit. So we've got our x, we've got our y, we've got our z axes. Okay, and this shape here is sort of like I'm trying to draw a plane. It's kind of difficult to draw a plane. You can draw a line in 2 dimensions fine, but this is sort of meant to represent a sheet of paper. It's basically a plane is like a sheet of paper, but it just continues infinitely in every direction. Okay, so this is what a plane is. Okay, and when you're drawing a line in 2 dimensions, the important things are your slope of your line, and if you know the slope, to find the equation, the only other thing you need is, you guessed it, a point. Okay, if you've got a point and a slope, you can find the equation for your line. Okay, for a plane, it's a little bit different, but a slope, there may be a way to describe a slope of a plane, but actually you would need probably 2 slopes. So there's actually an easier way to talk about the angle of the plane. All right, and that is by a perpendicular. So here, this n stands for normal, which means perpendicular. Okay, and so if you know a perpendicular vector, there's actually only one sort of slope of a plane that will be perpendicular to that vector, if you think about that. And so really, if we know a perpendicular vector and a point, okay, so if we know, well, basically a normal plus a point, so this is our n vector, and a point somewhere, in this example, this is our point ABC, is our fixed point. This will give us, this is enough information to find the equation. Alright, and if you think about how we found normals with this cross product that we've been using, and that was by, of course, taking 2 vectors, and if you make the cross product between 2 vectors, it gives you a normal to those 2 vectors. So this is just another thing to think about, is that if you have 2 vectors, that gives you a normal. And if you have 2 vectors and you know the exact location of those vectors, you've got a point somewhere. So you actually, if you're given 2 vectors, you can figure out the normal, and you can use one of the points to find an equation. And that's what we'll do in our example later. So in this diagram now, so we've got our fixed point, and this is our I don't know, I'll just call it a movable point. This x, y, and z are going to be in our equation somewhere. And actually, let me just show you what an equation will look like. Okay, so a line, one way to have a line equation is this. Okay, plane would be similar. Ax plus by plus, so we've got to add a z equals d. Okay, so this is what we're trying to get to. This is what we want our end result to look like. So these x, y, z are represented by this movable point r. Alright, so between this point P and R, we can make a vector P to R. Okay, let me draw that in here. P to R is a vector, and if you remember vector notation, that would be the same as going backwards on P, or negative P plus positive R, or just r minus p. Alright, and so using ijk notation, if you look at the x coordinate, we're going from a to x, so that is x minus a. That is our I coordinate. So from a to x is a total distance of x minus a. And same thing for the y, it's going to be y minus b. For the j, and it's going to be z minus c for the k. Okay, so this gives us a vector that is in the plane. Okay, that's a vector on the plane. And we know that that has to be perpendicular to that normal vector that we have, which we've just got generic notation. N is n1i plus n2j plus n3k. Okay, also because we haven't fixed any numbers in, but these two vectors are perpendicular always. And finding perpendicular vectors, what can you use? Well, you can use dot product. Dot product always tells you if two vectors are perpendicular, because what's the dot product when they're perpendicular? It's 0. So that's telling us we can just multiply the I coordinates, so that's n1 is the I for the first one, and x minus a for the other one, and so on. n2 times y minus b, n3 times y minus c. All of that equals 0. So that will give us the equation. Okay, so that's all we need to do. So, in our example, find the equation of the plane containing P1, 2, 1, Q, negative 1, 1, 0, and R, 1, 0, 2. Okay, well, I said we could find the equation if we had a point, and well, we've got 3 points, but I said we also needed a normal, and if you look here, we haven't been given a normal. But we got 3 points. What I could actually do with these 3 points, finding a normal, I've got my cross product that can find the normal. And the cross product needs 2 vectors. Now I've got 3 points. Let me just draw 3 points. Although this is in 3 dimensions, so it's not quite flat on the page, but I could make 2 vectors. I could make one there, and I could make one there. Once I've got 2 vectors, I can use my cross product and make a normal. So vector PQ is going to be from P to Q, I'm going a distance of -2. Basically, I can take my Q value, the -1, and minus my P value, which is 1. And that's the I. Next, I'm going to go to my Y value. So I've got a 1 on my Q, and I'm minusing 2. So that's a -1 or minus J. 0 minus 1, minus K. My other vector, PR. And I could have easily done RP or RQ, it didn't really matter. Any 2 vectors, and they didn't actually need to both be from the same point. It would have still worked the other way. Okay, now R is 0i. Okay, 0 minus 2, so that's minus 2j, and 2 minus 1 is k. 1k. Alright, so to find the normal now, I just have to do the cross product. And did it matter that I did it in that order? Could I have done it in the opposite order? I would of course get the negative of the normal, but it's still an anormal. All I care about is anormal. It doesn't even matter how long it is, whether it points up or it points down. Okay, so to do this, these are vector cross products. So I, j, k, -2, -1, -1, 0, -2, 1. So it equals I times -1 minus 2. So that is minus 3I. Okay, j. It's a minus j times a minus 2. So that is, I believe, a plus 2j. Now it's k times 4. Okay, so that's my normal. Now, I said the equation for a plane, we said, is n1, so remember, n1 x minus a plus n2 y minus b plus n3 z minus c equals 0. Okay, n1 is this minus 3. So minus 3 times x minus, now the ABC is just one of the points on the plane, which could be any of those three that we started with. So I'll just go with P, which is 1, 2, 1. Okay, I'm going to use P 1, 2, 1 equals my A, B, C. Okay, so x minus 1. N2 is 2. Y minus 2. N3 is 4. Z minus 1 equals 0. And what I could do is expand this. So minus 3x plus 3 plus 2y minus 4 plus 4z minus 4 equals 0. Combine my numbers. Let's see, minus 3x plus 2y plus 4z. I've got 3 minus 4 is a -1, minus 5, minus 4 is -5, I put it on the other side as a 5, and voila, I am done. Where's my stop?